Hello and welcome to high-resolution B-scan ultrasound of the anterior segment for the vitreoretinal surgeon. High-frequency ultrasound for the posterior segment surgeon usually involves problems with visualization. Anterior opacities, iris or pupillary changes, lens or pseudophakic position, ciliary body problems or tumors, and the region of the pars plana for any type of scar tissue or any other problem getting inside the eye. The history of this type of ultrasound dates back to Chuck Pavlin and Jack Coleman, both of whom developed laboratory instruments and then commercial units for performing anterior segment high-resolution ultrasound. But many things have changed and made it simpler and easier to use, and that's the reason for this presentation. Sterile covers, digital hardware, software, and real-time movie segments all make the images critical for the posterior segment surgeon, making surgery safer and in addition giving them some idea of the anatomy that's going to be involved. The images have made major changes. There's vertical presentation rather than horizontal, and the image registration therefore changes as well. The examination technique is quite simple with these changes: topical anesthesia, lubricant gel, the sterile covers with a water bath inside the sterile cover, and this apparatus acts like a water offset, so the contact technique of anterior segment is similar to the posterior segment. Axial, radial, and coronal images can be obtained without any difficulty. The axial examination can be seen here with the cornea clearly visible with a resolution of approximately 23 by 35 microns. The iris, the pupil, and the position in this case of a Sommering's ring cataract with an implant inside the capsular sac easily diagnosable. Radial imaging of the limbus is simple in that you just have to slip towards the clock hour that you wish, keeping the white dot towards the cornea and allowing a view of the iris, the ciliary body, and portions of the pars plana. If you rotate the probe 90 degrees with the water bath in place, you will obtain coronal images, and here the easiest way to get that is to slip from the central pupil, seen here, slowly towards the periphery, and the area of the ciliary body can easily be seen with the sulcus and then the ciliary body itself, and if you go further, the pars plana as seen in this particular portion of the movie segment. The ciliary body can be imaged a quadrant at a time with the ciliary body processes easily visible, and in this case silicone oil from previous injections with anti-VEGF material. The silicone oil is a contaminant of the needle and syringe. What makes a significant difference to me is real time. Up to now, most of the images that you've seen in anterior segment ultrasound have been predominantly stills. Real time means that the probe movement can be seen, or the patient movement can be seen, or spontaneous movements within the anterior portion of the globe can be seen. All of these in real time, and I'd like to show you some examples. Let's start with a hyphema, because a hyphema can be visualized quite easily with this technique. Here you can see the spontaneous motion produced by conductive changes between the cornea and the hotter portions of the iris. In this case, the iris is slightly bent backwards towards that residual cataract. An angle recession can be seen as you rotate the probe in a radial image. Here you can see the ciliary body has been split, whereas you couldn't see it when you first went on until you got to the area of the angle recession. And then finally, looking at a mobile capsule when the eye moves and the induced movement of the capsule remaining bag in this iris fixated lens with the ciliary body processes and zonules visible. The zonules can be seen broken, at least some of them, and the movement of the capsular bag easily visualized. Pattern recognition is just similar to the pattern recognition seen with posterior segment surgery. Here we can see some anterior secondary lens cysts blocking the pupillary opening with an implant seen directly behind it and a Sommering's ring cataract. A YAG laser in this patient restored his vision. His pupil could not be dilated, and posterior segment ultrasound was also performed. An anterior chamber clot with no movement can easily be visualized in this hypotenuse eye, and it can be noted that the clot itself pushes the iris back quite far. A flat chamber in a glaucoma tube procedure reveals the iris against the back cornea, and no tube is visible. What happened to the tube? Well, visualization with this technique demonstrates the iris up against the back of the surface of the cornea and the tube seen directly in front of the implant down and to the left of the screen as it enters the posterior chamber, the anterior chamber being completely flat. A trapped IOL can easily be visualized in this patient with a portion of the optic behind the iris to the left and above the iris to the right. IOL positions are easily delineated by this technique. Here in the center axial view, the pupil can be seen some iridodenesis and the lens moving slightly as the patient's saccadic movements demonstrate movement of the implant as well. As the lens goes further and further posterior, it is possible to see the distance between the iris and the implant and the residual lens material within the capsular sac. And in this situation, the IOL has slipped well below to the 6 o'clock position over the pars plana. You can also see some artifacts produced by perfluorocarbon liquid that has accumulated from previous surgery in the pars plana region. Those peculiar comet-like effects are typical of foreign body images of ringing. In this case, it is residual perfluorocarbon small bubbles. The ciliary body haptic can be seen eroding into the ciliary body in this particular case of recurrent bleeding. One of the reasons that it's easy to see this by ultrasound prior to any attempt at wiggling or moving the implant inside the eye, which might induce further bleeding. Pars plana traction can easily be seen as an extension of the peripheral traction of this retinal detachment at the 7 o'clock position, and avoiding this area might be wise, especially when the incisions are to be made with smaller gauge trocars. Silicone oil can be seen just behind the ciliary body processes in another case where residual silicone oil has been left behind by the insertion of multiple needle tracks for the implantation of anti-VEGF material. An entire pars plana tube can be visualized easily, in this case with an opaque cornea and the tube going through the pars plana, through the sclera and under the lid. Some of the lashes can actually be seen to the right of the screen as well. And finally, the sclera, visualized quite easily here with a color photograph demonstrating a bluish-black change to the sclera. This was the result of a long-standing 8/0 nylon suture that had not been removed next to a 20-gauge incision. And this area can be seen just behind the ciliary body as a small indentation in the left 1/3 of the pars plana region. In this case, it looks like there are two corneas, but the real one is to the right. The iris is seen rising up to the sclera, to the center of the screen, and the ciliary body processes and zonules are more difficult to see but are to the left. In this situation, there is also some anterior segment and inflammatory tissue moving around in the inside of the eye, and the patient's lens is still in place behind the iris. In this situation, a posterior B-scan of the same area demonstrates a defect in the scleral wall at the superior portion of the screen, and a color photograph demonstrates this bluish-black change to the sclera where the sclera has been thinned and is dehisced sufficiently or melted away so that this large bullish change is visualized. There was no tumor in this particular case. So in summary, high-frequency ultrasound has basically changed. It's become easier to perform. Real-time imaging really does change your diagnostic capabilities, since none of these changes that I've shown you would be easily visible without real-time. Patient acceptance is high, and the diagnostic aid to a vitreoretinal surgeon, I think, are pretty obvious, especially when information is needed from the anterior segment. I hope you've enjoyed this short presentation. There will be many more to come to help delineate pattern recognition for the anterior segment, as we have already put together a library for the posterior segment. Thank you for your attention.